my dinner. So, stupid thing, zooming in and out. Sketch the curve with the equation y equals k over x. Most of you did that pretty well. You remembered what the graph of a reciprocal function looks like. You remembered that it has those asymptotes with the y and x axes. So it sort of swoops down like that. And you remembered that it exists in quadrants 1 and 3. And it looks something like that then. Pretty much everyone got that mark, so well done. Part B, a bit trickier, hence or otherwise solve this. This is one occasion where personally I would go for the otherwise rather than the hence. So I'm not going to use my diagram to do it. What I'm going to do instead is I'm going to set up a quadratic inequality. The reason it becomes a quadratic inequality, you should remember, is that if x is a negative value, then when I multiply by x to clear it away from this denominator, that would flip the inequality sign around. So because I don't want to do that, I don't know whether x is positive or negative, if I multiply through by x squared, which is always positive, no matter what value x takes, unless it's 0, but we know it isn't, x is not 0, then that eliminates that problem because the inequality is going to stay pointing that same way. So if I multiply both sides of this by x squared, that would give me 16x on the left is less than or equal to 2x squared. Bring the 16x over, 0 is less than or equal to 2x squared minus 16x. Factorize, common factor 2x, open bracket, x minus 8. So that means that x equals 0 and x equals 8 are the critical values. So I just sketched that quadratic like we did earlier in question 1. X equals 0. Oh, I missed that line completely. Let me just start again. I've got too much axis on the left there. It's lagging a bit, this drawing tablet. I've done again, all that axis on the left. I don't want it. I never said I could draw. Okay, right, there's my axes. So I'm going to go through 0 and 8, because they're my critical values. I want the region where 2x squared minus 16x is greater than or equal to 0. So the region where the curve is positive is to the right of 8 and to the left of 0. So x is less than or equal to 0, or x is greater than or equal to 8. Okay, but the question told us, remember, x isn't 0. So we can't say that x is less than or equal to 0 because we know it isn't equal to 0. It's just less than 0 then. Our other value can stand as it is. X is greater than or equal to 8 would lead to 2x squared minus 16x being greater than or equal to 0, which is what we want. And those are our two values. The other way we could do it is using the graph, really. If you sort of look at your sketch, you could put a line in that represents this being the line of y equals 2, intersecting at 2. I guess this is a pretty good way to do it. And deducing from that sketch then that because we want it to be less than or equal to 2, it's less than or equal to 2 for all of these values here, and these are the values where x is less than 0. So that gives us that first bit. It's less than or equal to 2 for all of that. But then we've got to go ahead and find, well, what's the value here, where that curve intersects this line. That then we could just find, we know it's positive, so we don't have to actually worry then about flipping the inequality sign. We can see that's a positive value of x, so we can just multiply by x, giving us 16 then is less than or equal to 2x, which means x is greater than or equal to 8, and that gives us this bit. I suppose that's probably easier, really, isn't it? But it just requires that we deduce this first part, that x is less than 0, because all of those values are in the region that we want. Whereas if we set up the quadratic, we can see, we get that answer. It's part of our solution set in the first place. So 6 and 1 1/2 doesn't have the other, really, I think, as to which way you do it.